Welcome back to Crushing Design Patterns in .NET. In our last episode, we learned how the adapter pattern can bridge incompatible interfaces. Today, we are asking a different question. How can you add new features and responsibilities to an object dynamically without creating a complex web of subclasses? The answer is an elegant structural pattern that lets you wrap your objects with new functionality, the Decorator pattern. Let's see how our expert Arohi uses this pattern to build a flexible data saving service. What is the initial problematic approach that many developers might try?
The most common mistake would be to modify the original file report service and add Boolean flags or parameters to its save method. This quickly becomes a nightmare. What if we add a third option, like adding a timestamp? The number of if statements and combinations explodes. This approach violates the single responsibility principle. The class is doing too much, and the open-closed principle. We have to modify it for every new feature. Another bad approach is using inheritance, which would lead to a class explosion like encrypted report service, compressed report service, encrypted and compressed report service, etc.
How does the Decorator pattern offer a cleaner solution?
The Decorator pattern allows us to attach new behaviors to objects by placing them inside special wrapper objects that contain the behaviors. It's a flexible alternative to subclassing for extending functionality. We start with a core object and then decorate it, layer by layer, with the new features we need at runtime.
What are the key components needed to implement the Decorator pattern?
There are 4 main roles. Number 1, the component. The common interface for both the object we are wrapping and the wrappers themselves. Number 2, the concrete component. The original core object that we want to add functionality to. Number 3, the decorator, an abstract base class for our wrappers. It implements the component interface and holds a reference to a component object. Number 4, concrete decorators, the actual wrapper classes that add the new responsibilities.
Let's build it. What does the base component and the concrete component look like?
First, we define our IReportService interface, which is our component. Then, we have our basic file report service, which is the concrete component.
How do you create the abstract decorator base class?
This is a key step. We create an abstract class, ReportService that also implements IReportService. Its purpose is to hold a reference to the object it's wrapping and to pass the call through to that wrapped object.
Now, how do we implement the concrete decorators for compression and encryption?
We create new classes that inherit from our ReportService decorator. Each one overrides the save method. It first adds its own new behavior, and then it calls the save method of the object it's wrapping.
This is very flexible. How would the client code stack these decorators at runtime?
This is where the power of the pattern becomes clear. The client can now compose the exact functionality it needs by wrapping the objects like Russian dolls. The order of wrapping matters, and the client has full control over it at runtime.
Which solid principles does the Decorator pattern strongly support?
It's a fantastic example of both the open/closed principle and the single responsibility principle. Our system is open to having new features like encryption added, but the core file report service is closed for modification. And each decorator class has the single responsibility of adding its specific feature.
How does the Decorator pattern compare to the strategy pattern?
They are both behavioral patterns that use composition, but their intent is different. The strategy pattern is concerned with swapping out an entire algorithm. You choose one strategy or another, for example, pay with PayPal or pay with Stripe. The Decorator pattern is concerned with adding responsibilities on top of an existing object. You can stack multiple decorators, for example, save the file and compress it and encrypt it. Strategy changes the inner workings of an object, while Decorator changes its outer capabilities.
When should an interviewer see you reach for the decorator pattern?
The Decorator pattern is the ideal solution when you need to add functionality to objects dynamically and transparently without affecting other objects. It's the answer when you hear keywords like optional features, stackable behaviors, or wrapping functionality. When using inheritance would be impractical because of the sheer number of potential feature combinations, the Decorator pattern is a clean, scalable, and professional alternative.
Where do we see the decorator pattern in the standard .NET library?
The most famous example is the system.io.stream family. You start with a buffered's functionality, then you wrap it in a buffered stream, and then maybe a crypto stream or gzip stream. Each layer adds a specific responsibility: buffering, encryption, or compression, while still looking like a simple stream to the rest of the application.
How do we implement the decorator pattern using the built-in .NET Core Dependency Injection container?
This is a tricky one. Manual wrapping in program.cs can get messy. Usually, we use a library called Scrutor. It allows you to register decorators elegantly using a syntax like services.decorateparens. Without Scrutor, you have to manually resolve the inner service inside a factory delegate, which is more prone to errors.
Does the order of decorators matter?
Absolutely. It's an architectural decision. Think about our example. If you encrypt the data first and then try to compress it, the compression will be very inefficient because encrypted data is essentially random. You should compress first, then encrypt. As an architect, you must control the stacking order to ensure system performance.
How does the decorator pattern differ from the proxy pattern?
They look identical in code, but their intent is different. Decorator is about adding behavior, compression, encryption. Proxy is about controlling access to the object, lazy loading, authentication, logging. A decorator adds what the object does. A proxy controls when or if the object does it.
Can we use generics to create a universal decorator?
Yes, we can. We can create a generic logger decorator where T is an interface. However, in C#, this is difficult because the decorator must implement all methods of T. For cross-cutting concerns like logging or caching, we often use aspect-oriented programming, AOP, or interceptors like those in Castle Core or AutoFac instead of pure decorator patterns.
What is the performance impact of having 10 or 20 layers of decorators?
Technically, each layer adds a tiny bit of overhead because of the extra method call on the stack. But unless you are building a high-frequency trading system, the impact is invisible. The real performance cost is the complexity for the developer trying to debug 20 nested wrappers. Keep your Russian dolls meaningful.
How do you unit test a decorated object?
The beauty of this pattern is that you test one thing at a time. You write a test for encrypting decorator and pass in a mock IReportService. You only test that the encryption logic works. You don't need to test the file saving or the compression in the same test. This isolation is what makes the pattern so robust.
Can a decorator change the method signature of the core component?
No. If you change the signature, you are no longer implementing the interface, and you break the Russian doll stacking. A decorator must be transparent to the client. If the client expects save report R, the decorator must provide exactly that.
Is ASP.NET Core middleware an implementation of the decorator pattern?
It's very similar. Middleware components wrap around the each other course neck. Each middleware can do something before the next one, like authentication, then call the next delegate, and then do something after, like logging the response time. It's essentially a chain of responsibility mixed with the decorator concept.
What is decorator hell and how do we avoid it?
Decorated hell happens when you have so many wrappers that it becomes impossible to track which object is doing what at runtime. To avoid this, use a fluent interface or a factory to build your decorated objects. Don't let the Russian dolls get scattered all over your code. Centralize their creation in the DI container.
Arohi, that was brilliant. You've shown us how to use the decorator pattern to build incredibly flexible and layered systems, breaking free from the rigidity of inheritance. If you're now ready to decorate your own objects with new functionality, give this video a like and comment below with your favorite decorator from this example, compression or encryption. And don't forget to subscribe to the .NET Way. In episode 9 of Crushing Design Patterns, we're going to dive into a pattern that lets you turn a request into a standalone object. It's time to learn how to undo, redo, and queue operations with the command pattern. Thanks for watching. We'll see you in the next episode.